Hello students, we had discussed the term modular arithmetic in previous video. Today we will discuss operations such as addition, subtraction, multiplication and division in modular arithmetic. Let's start. Let a, b, c, d and e be integers and let n be a non-negative integer. For addition in modular arithmetic, if a plus b is equal to c, then a plus b modulo n is congruent to c modulo n. Also, a plus b modulo n is congruent to a modulo n plus b modulo n. Modular addition can be considered as counting forward in a clock. Let's work in modulus 12. Assume it is 6 and we want to know what time it will be 11 hours from now. Basically, this is asking us to find 6 plus 11 modulo 12. To perform this operation, we first add 6 and 11 to get 17. So, 6 plus 11 modulo 12 is congruent to 17 modulo 12. Next, we find 17 modulo 12. To find 17 modulo 12, we find the remainder when 17 is divided by 12, which is 5. Therefore, 6 plus 11 modulo 12 is congruent to 5 modulo 12. This tells us that if it is 6, then 11 hours from now, it will be 5. Next, subtraction in modular arithmetic. If a minus b is equal to c, then a minus b modulo n is congruent to c modulo n. Also, a minus b modulo n is congruent to a modulo n minus b modulo n. Modular subtraction can be considered as counting backward in a clock. For instance, what is 1 minus 3 modulo 12? If we start at 1 o'clock and then counting backwards 3 hours, we would be at 10 o'clock. So, 1 minus 3 modulo 12 is congruent to 10. Next, multiplication in modular arithmetic. To perform multiplication in modular arithmetic, first perform the normal non-arithmetic multiplication and then change that number into its modular form. So, let's find 6 into 13 modulo 12. First we multiply 6 with 13, it is 78. So, 6 times 13 modulo 12 is equal to 78 modulo 12. Now dividing 78 by 12, we get 6. So, 6 into 13 modulo 12, that is 78 modulo 12 is congruent to 6 modulo 12. Similarly, we can do large calculations. Let's find 7 raised to power 13 modulo 5. 7 raised to power 13 modulo 5 is congruent to 2 raised to power 13 modulo 5, as 2 is remainder when 7 is divided by 5. So, 7 raised to power 13 modulo 5 is congruent to 2 raised to power 13 modulo 5, which can be written as 2 into 2 raised to power 4 whole power 3 modulo 5, that is congruent to 2 into 16 raised to power 3 modulo 5, which is congruent to 2 modulo 5. Next is division in modular arithmetic. Likewise, multiplication in modular arithmetic, you can first perform the normal non-arithmetic division and then change that number into its modular form. For instance, 1600 by 25 modulo 12 is congruent to 64 modulo 12, which is congruent to 4. I hope you had a clarity regarding the topic today and wish it's going to be fun for you learning mathematics. Thank you.